Throughout history, firearms have existed in a wide spectrum of forms, ranging from large-scale artillery designed for strategic impact to compact sidearms built for personal use. Each category reflects the manufacturing standards, materials, and engineering priorities of its era. These objects, regardless of size, serve as mechanical records of the time in which they were produced, revealing how designers balance durability, reliability, and available technology. Within this spectrum, the 1911 platform occupies a unique position. It represents early 20th century engineering principles, simplicity of operation, robust machining, and the ability to function under demanding conditions. Many examples have survived in serviceable condition for decades, but others have endured far harsher environments. The pistol featured in this episode is one of those examples. What remains today is a sidearm heavily marked by time. Its surfaces corroded, its components seized, and its origins partially obscured by years of exposure. The extent of internal damage is unknown, and the degree to which the original structure has survived cannot be determined from the exterior alone. This documentary begins by examining the firearm exactly as recovered, treating its condition as evidence of the circumstances it experienced. We analyze surface patterns, remaining markings, and the visible progression of corrosion to understand its history. From there, the restoration is documented step by step, with attention to how each layer of deterioration reveals more about the pistol's past and the engineering principles behind its design. At the center of this investigation is an open question. After years of environmental damage, can this mechanically precise platform return to functional operation? The answer is uncertain, and uncovering it forms the direction and purpose of the entire episode. The 1911 pistol holds a unique place in both military and civilian history. First introduced in the early 20th century, its design represented a major leap in sidearm engineering. Solid steel construction, straightforward mechanical geometry, and a reputation for reliability made it a widely adopted platform across multiple branches of service and later among civilian owners. Over decades of production, countless manufacturers, both military contractors and civilian firms, created their own interpretations of the design, each retaining the core principles set by the original blueprint. The example in this documentary shows how time and environment can alter that legacy. Although corrosion obscures many details, the pistol's silhouette still reflects its lineage. The angular slide profile, the grip frame geometry, and the placement of the controls point toward a traditional military pattern configuration. Even where markings have been softened or lost, faint impressions remain, small clues to its manufacturing origin. These remnants help narrow down the production era, the likely maker, and the role the firearm may have served before its decline. The conditions that led to its current state are equally revealing. The depth of the pitting suggests prolonged exposure to moisture-rich environments, possibly involving repeated cycles of wet and dry conditions that accelerated oxidation. The frame and slide surfaces show evidence of uneven corrosion patterns, indicating the pistol may have been stored or abandoned in a way that exposed certain areas more than others. Grip materials reveal their own form of degradation, providing additional insight into temperature changes, humidity, and long-term contact with surrounding materials. Even without a complete historical record, the firearm itself becomes a document of its past. The wear patterns, discoloration, and compromised surfaces act as physical indicators of how long it remained untouched and the types of conditions it endured. In some areas, the corrosion appears layered, suggesting multiple phases of environmental exposure over time. In others, the metal shows signs of stress or material thinning that hint at the gradual progression of decay rather than a sudden event. The pistol's journey to this state of deterioration illustrates not only the vulnerabilities of steel under certain conditions, but also the endurance of early 20th century manufacturing principles. Even heavily corroded, the underlying structure still retains enough form to reveal its identity. The story embedded within the metal part history, part environment, part neglect, sets the stage for the restoration that follows. It provides the necessary context to understand both what has been lost and what might still be preserved. At recovery, the 1911 pistol displays extensive and well-advanced deterioration. The slide exhibits deep pitting across its length, with corrosion obscuring most surface features and leaving only fragments of the original machining visible. The frame shows similar damage, particularly along the dust cover, front strap, and trigger guard, where extended exposure has altered both the texture and profile of the steel. All major external controls are immobilized. The safety, slide stop, and magazine release remain fixed in place under dense layers of oxidation, preventing any initial determination of their underlying condition. The grip panels, severely compromised by moisture and environmental stress, provide little structural support and offer evidence of long-term exposure cycles. Internal components are assumed to be in comparable condition. While their exact state cannot be confirmed until later stages, early indicators, such as corrosion at the junctions where parts meet, suggest significant surface degradation and possible material loss. Areas that normally rely on precise fitment show visible distortion, implying the original tolerances have been affected. The barrel's exterior presents heavy scaling and discoloration. Any remaining rifling, chamber clarity, or bore condition remains unknown at this stage, but the exterior corrosion suggests prolonged contact with moisture and debris. Pins, springs, and contact surfaces also show signs of advanced rust patterns, indicating that internal movement has been compromised for an extended period. This assessment establishes a factual baseline for the entire restoration process. By documenting the pistol exactly as it appears at the moment of recovery, we gain a measurable reference for evaluating how much of the original structure can be preserved and what insights the restoration may reveal about the firearm's history and material endurance. The restoration phase begins with the gradual removal of surface corrosion, allowing the underlying steel of the 1911 pistol to be observed for the first time. As the exterior layers are reduced, the original contours of the slide and frame reappear, revealing machining lines, edges, and transitions that had been concealed beneath oxidation. Areas previously assumed to be structurally uniform prove to have varying depths of corrosion, showing how environmental conditions affected each section differently. Markings that were either faint or completely obscured begin to reveal partial legibility. Serial ranges, manufacturer identifiers, and proof marks emerge at differing clarity levels, providing additional clues to the pistol's production background. These recovered details help confirm whether the firearm aligns with a specific era or manufacturing variant and enable more accurate documentation of its historical placement. As internal areas become accessible, components are examined for material integrity. Springs show varying degrees of fatigue, contact surfaces reveal the extent of metal loss, and engagement points indicate how deeply corrosion penetrated into previously sheltered spaces. Some parts retain recognizable geometry, while others display rounded edges, discoloration, or surface thinning that indicate long-term deterioration. The interaction between the slide and frame becomes a focal point. As corrosion is reduced, their alignment becomes easier to evaluate, highlighting which areas retained shape and which were altered by oxidation. The gradual clarification of these surfaces helps determine how closely the pistol can return to its original mechanical relationships. Throughout this phase, the firearm transitions from an unrecognizable artifact into a clearer representation of its original engineering. The process documents how early 20th century steel responds to prolonged neglect, demonstrating both the durability of certain structural elements and the vulnerability of others. By the end of the restoration phase, enough of the pistol's original form has been revealed to allow for a measured and informed mechanical evaluation. With the restoration phase complete, the 1911 pistol undergoes a structured evaluation to determine how its recovered components interact as a mechanical system. This assessment focuses on movement, alignment, and material stability rather than performance claims, providing an objective view of what remains functional after years of deterioration. The slide and frame relationship is observed first. Their interaction reveals how well the original geometry has been preserved. Areas where metal loss occurred show minor changes in tracking, while more intact sections reflect the durability of the platform's design. This comparison allows for a clearer understanding of which surfaces maintained their integrity and which were most affected by corrosion. Major controls, such as the safety, slide stop, and magazine release, are examined for consistent and predictable movement following restoration. Their engagement points display varying degrees of wear, offering insight into how long they may have been immobilized and how environmental exposure affected each part differently. The barrel's condition becomes more evident during this stage. External corrosion patterns contrast with the remaining interior features, revealing how the bore endured prolonged exposure. Whether rifling remains clearly defined or partially eroded provides additional context for assessing the pistol's retention of its original design characteristics. Basic mechanical cycling is monitored to understand the pistol's overall behavior as a restored system. These observations highlight whether the remaining tolerances support coherent movement or if long-term corrosion created deviations from expected alignment. The timing, return paths, and points of contact all offer valuable data regarding the firearm's structural recovery. This evaluation does not assume full restoration to factory standards. Instead, it documents the practical outcome of restoring a heavily corroded 1911 and provides a factual baseline for the supervised testing that follows. The resulting information forms a bridge between the physical recovery of the firearm and its final assessment. The restoration of this 1911 pistol demonstrates how historical firearms can serve as physical records of their past. What began as a severely deteriorated object, obscured by corrosion and long periods of neglect, gradually revealed a clearer picture of its construction, environment, and resilience. Each phase of the process contributed evidence about the limits and durability of early 20th century steel, as well as the long-term effects of uncontrolled exposure. The recovered markings, clarified surfaces, and re-established component relationships show how much of the original design remained intact beneath the decay. At the same time, areas of thinning, distortion, and wear highlight the irreversible impact of prolonged environmental stress. Together, these findings provide a balanced understanding of what was preserved, what was lost, and what can be learned from the pistol's condition. This project underscores the value of documenting restorations in a systematic way. Studying a firearm in this state reveals not only its mechanical qualities, but also the broader contexts that shaped its decline: storage conditions, environmental cycles, and the passage of time. By contextualizing these observations within the pistol's historical framework, the restoration becomes more than a physical recovery. It becomes an opportunity to interpret how materials age and how engineering endures. The restored 1911 stands as a clearer, more complete representation of itself, though permanently marked by its journey. Its final state reflects both the strength of the original design and the realities of long-term decay. The documentary record preserves this balance, providing insight for future examinations of firearms with similar histories. This restoration provides a detailed look at how a historic firearm responds to decades of exposure, neglect, and material breakdown. By examining the 1911 before, during, and after restoration, we gain a better understanding of the design principles that allowed it to endure and the environmental factors that shaped its decline. Documenting these transformations creates a permanent record, one that preserves the pistol's story even as its physical condition evolves. For those interested in the engineering, history, and preservation of firearms from past eras, continued engagement helps support the creation of future studies. Each project offers a new opportunity to investigate how time affects mechanical systems and how restoration can reveal the evidence hidden within them. If you wish to follow additional restorations or explore similar historical artifacts, subscribing and enabling updates ensures you won't miss upcoming examinations. Your participation allows this documentary work to continue and contributes to the ongoing effort to preserve and understand mechanical history. Thank you for joining this exploration of the 1911 pistol's life, deterioration, and restoration.